I am Anil Kumar, and in this video we'll apply our method of 5 points and 2 steps to sketch the transformed sinusoidal function. So the question here is sketch graph of y equals to minus 2 sine of half of x plus 30 degrees plus 1. Now in the very first step, what should you do? You should rewrite the equation in the standard way. It should be written as y equals to minus 2 sine. Always factor the coefficient of x, right? So let's factor half. So when you factor half, you get x. Within the bracket, you get plus 60 degrees. Do you see that? Plus 60 degrees plus 1. Now you have the correct phase shift, which is 60 degrees left, right? And the time period. Time period will be, in this case, 360 divided by half, which is 720, right? So that is your time period. Now, the two-step method which we have been talking about is to incorporate stretches, compressions, and reflections in the first step, and translations, both horizontal and vertical, in the second step, right? So let's look into this particular function. It is minus, that means sine wave will be reflected. So basically, we are looking for a sine wave which is going to be like this, right? This simple sketch is only for you to understand how we are going to sketch it here. So in the first step, what we will do is we will sketch the function y equals to minus 2 sine of half x. This is what we will do first, correct? Now half x means what? Half x means that we have a time period t which will be equals to 360 degrees divided by half, or 720 degrees, correct? So that is going to be the time period for us. And we know amplitude is equals to 2. So let us sketch this function y equals to minus 2 sine of half x. To sketch this function, let's see the scale first. We need 720 degrees, right? So if we go with 30, so if we go with 30, we get 30, 60, 90. We can go with 30 and let us see. So 30, 60, 90, 30, 60, 90, 30, 60, 90, 30, 60, 90. Okay. So, and 60 degrees. Okay. So let's see the horizontal scale first. So what we will do is we will take each unit as let us say 30 degrees. We may have to so we have to go to 720 degrees. Let's go with 1, 2, 3, 4 as 1/4 of 720, that is 90 degrees. Okay, so let us say this is 90 degrees for us. Now as you see, we have a phase shift of 60 degrees, so it is good to have each small division as 60. Right? Let's take each small division as 60. In that case, let me use a different ink now. If we have 60, so 60 times 3 is 180, right? So this will be 180. We are taking that as 60 degrees. So each division will be 60 degrees. 3 of those will give us 180 degrees, right? So 1, 2, 3, that becomes 180. 1, 2, 3, that becomes 360. That is half of this cycle. Now 1, 2, 3, another 360, and then 180, and then 1, 2, 3, 720. So that is where the cycle ends. So these are the four different quarters of the time period we are considering. Now the amplitude for us is 2 and should goes downwards. So for 2, let us say the scale is 1. Let's say these 2 divisions are 2, right? So 1 division each for 1, so it becomes 2. So we are taking this as 1 minus 2, and 2. So that becomes our scale now, correct? So what we have here is, let me write down the scale correctly. We have 360 degrees, 720 degrees here, right? Half is 360 degrees, then half is 180 degrees. And then we add 180 degrees to 360 to get 540 degrees, correct? So the 5 points which we're talking about will start from origin, and then amplitude is 2. Negative means reflected, so we get minimum. So at 180 we get minimum, then back to 0, and then to maximum, which is 2, and then back to 0. So this particular function for us is the sine function we're talking about, which has been reflected and stretched. Do you see that? So this is the first part, correct? Now we'll incorporate the translations. So the translations for us are, let's look into those translations. 1 unit up and 60 degrees to left, right? So this is 60 degrees left and 1 unit up, right? That is the translation. 60 units is 1 division for us. So we'll go 1 left and 1 unit up. So this point will move left and up, so it will come here. Do you see that? Here also we'll move 1 unit left, which is 60 degrees, and 1 unit up, so that comes to this point. So that is the translation. Do you see that? And then again same thing, 1 and 2. So these are the horizontal and the vertical translations. Once you get these translations, connect your point, right? So I'm not very sure about whether it goes to the origin at that point or not, but just connect them, right? So we could find it later. Okay, so if you, so that is how it is, right? So it should not go probably just like this, right? So that is how you get your final graph, and this final graph which I've drawn represents y equals to minus 2 sine of half x plus 30 degrees plus 1, right? Now it's a good idea to check whether the graph is right or not. So from the equation it is clear that y equals to 1 is your axis. So let us draw an axis here and see whether our 5 points, 3 of them lie on this axis or not. They do. So this is y equals to 1 and 3 points are on this axis. How about maximum and minimum? Maximum should be at 1 plus 2, which is 3. So is this 3 for you? Yes, it is. Perfect. Minimum should be 1 minus 2, which is minus 1. That is also correct. And the time period is right, we know. And it ends and starts where? It should start at minus 60. That is right. Starts at minus 60 degrees. And it should end 60 degrees less than 720. That is 660 less will give us 40, right? So 660, correct. 660 degrees will be 60 less than 720, correct? So that is going to be our final wave. I hope that helps you to understand the concept of sketching sinusoidal function. So the method used is, consider 5 points for sine which are 0 normally, which are 0 maximum, 0 minimum, 0. Since it was reflected and stretched, we went downwards first, right? And then once you have sketched your stretched, compressed and reflected graph, translate horizontally and vertically to get your final graph. I hope that helps. Thank you and all the best.